and welcome back to KIS Academic. Today we'll be studying Chapter 7, Differential Equations. Our study objectives for today would be an introduction to differential equations, looking at integrals as differential equations, finding solutions to differential equations, and we'll also go through some practice questions. So, first of all, what are differential equations? Differential equations, I will now write out a few for you. So they are things where you have the derivative as part of the equation. So some examples would be y dash equals negative 7y, or you can have things like y second derivative equals minus 7 times the first derivative plus y plus xy. So those are differential equations. So the first thing we have to learn is the order of a differential equation. So the order is determined by the highest order of y in the equation. So for the first one, we see that we have y dash. That means that the order of that would be 1. So I'll write this in red. So this is order 1. The second one, again, same, because y dash is the highest order. That'll be order 1. But the next one, we have y second derivative, y double dash. So that will be order 2. So that is what we mean by the order of the differential equation. So then, looking at solutions to differential equations and how we can prove them. The solutions to differential equations are usually equations with x and y. So they are sort of like functions. So it's not always going to be a number or a constant. It can be an equation. So let's have a look at the first example there. Show by substitution that the given function is a solution of the differential equation. So the solution is this one over here, and we can see that it is an equation in terms of x and y. And this one, so I'm going to highlight it in red. This is the differential equation. And this one here is one possible solution. So how do we prove that it is a solution? Well, what we do is we will have to show that left-hand side equals right-hand side in the differential equation. So first of all, I'm going to derive y equals x squared minus 2x plus 3. So y dash equals 2x minus 2 and y double dash equals 2. So then, if we sub those things into the left-hand side, x squared times 2 minus 2x times 2x minus 2 plus 2y, 2x squared minus 4x squared plus 4x plus 2. Now y is x squared minus 2x plus 3. So we want everything in terms of x. That gives us 2x squared minus 4x squared plus 4x plus 2x squared minus 4x plus 6. So we can see that 2x squared plus 2x squared gives us 4x squared, and that cancels out with the negative 4x squared, and then 4x cancels out with 4x, so we're left with 6, which is the right-hand side. So we can say that it satisfies the differential equation. And I'm just going to use DE for short, therefore it is a solution. Okay, so now onto the next part. Indefinite integrals are differential equations. What this means is, say we have an integral, so integrate 2x dx. That is the same as saying find a function with derivative 2x, because when you integrate that, you should get the original function. So if we're saying that, then what we're really saying is that y dash equals 2x, and that there is a differential equation. So from here we can see that if we have to integrate something, a function, that is the equivalent of the differential equation y dash equals fx. And a solution to that would be, if you integrated it, you get x squared plus c. So if we integrate this, we get x squared plus c. Therefore, y equals x squared plus c is a solution to the differential equation y dash equals 2x. And here we come to the second point, which is about the general solution. So the c is an arbitrary constant, so it can be anything, which means that this formula, this function that we've just written down, is in fact the general solution, because it is not specific, it does not specify what c, the constant, is. So another note about general solutions then is that in a general solution, so that's when you integrate the derivative, you get constants. So one rule that we know is that the number of constants in the general solution is equal to the order of the differential equation, which makes sense if we think about something like the next question. So solve the following second order differential equation y double dash equals 2. If we integrate it twice, we're going to have to find two different constants. So if I try to do this question, then I get, so the first one is y dash, which is integrate 2, which is 2x plus c. So that's my first constant, but we want the solution in terms of xy, so I have to integrate that again. So integrating 2x plus c dx gives me x squared plus cx plus d. So here you can see that we actually do have two distinguishable constants, which works because this is a second order differential equation, and that there would be my general solution.